Okay, hello. Let's go ahead and set this up here. Today we're going to be looking at the array list, which is like an array, but it's able to grow and shrink, and it's got a lot of cool fun stuff in there. Let's get started. The first thing to understand about an array list is that it is using something called a list. And that is stored in the Java util library. I'm going to go ahead and import both of those things. The list itself is what's called an interface. Interfaces are basically outlines of classes, whereas ArrayList is the child class that implements list and it fulfills all the requirements of it. Whereas list spells out a bunch of functions that it needs to be able to do and such. The ArrayList will actually do them. Let's explain what that means. So let's say I make a new array list. This is going to be an array list called L1. Say equals new array list. I'm actually going to go ahead and specify a type because I want you to see this diamond syntax here. So let's say I'd make a new array list of type string. As always, there is a constructor here, so you need these parentheses. This diamond thing tells us what kind of array list we're going to have. Obviously, that is a little bit different from if you had an array itself. But won't go too much. Won't worry with that right now. We'll just focus on the array list. So that is different, but this is now what we call an array list. And so array list can do the following things. In this section of the video, we're just going to focus on adding elements. All right. We added 3 new elements, and right there you'll notice I never said how big the array list is going to be, but as I add elements to L1, it is now grown to 3. And we can see that by accessing the size method. So if I were to go ahead and print out L1.size, arrays were length, array list has size, just so you can keep that in mind. And it is a method, so it needs to have these parentheses. You can see how that works. And we get 3. Right? Makes sense, right? Perfect. All right. We're going to go on. We're going to actually shrink down to 2. And I'm going to do that by removing one of the elements. I'm going to remove the element at 0. So you should see now that we're down to 2. This removal works like this. It's going to remove whatever element is at that index. Keep in mind, your indices are 0, 1, 2. They start at 0, and so it's going to remove that first one right there. Alright, so let's get into some more theoretical stuff. We said that ArrayList implements list. Well, that's a lot like how a child class inherits from a parent class. When it implements it, it's technically both of those objects. So if we were to make L1 again, but this time as a list, set equal to new array list, and I'm going to do this time, make it an integer. I'll show you what exactly that means by making it an integer. And at the same time, I'm also going to make a much less descriptive list. That's just going to be of type array list. And then I'm going to have one more list, and we're going to just have it like this. So with these 3 lines, first thing we got to get out of the way is that this one's invalid. It's invalid because list is an interface. We say it's abstract. It's not supposed to be on the right side of this equal sign. Basically, any of the things where we say it implements, any of our interfaces, cannot be over here. So we can have We can have these two. These are fine. We can specify a certain type for this array list, or we can leave it alone. But in whichever case, we need to make sure that ArrayList is on the right side. It does not matter if it's ArrayList or list on the left side. It will be the same exact result. So let's go ahead and go into what that actually means. We have this part that says integer, and just like any other integer, we're going to add it as numbers. So I'm going to add in a few numbers, 5, 6, 7, perfect. We can ignore the warnings. As you can see, that will come out just fine. By the way, here is printing. So by the way, here is printing. And you print it out. You can actually just print out the thing itself. Remember that when we tried to do that with an array, it just printed out like the sort of the location in memory. In case you've forgotten, it looks something like this. So this is sort of the location memory, not technically, but we can say it basically is. But when you try to print out an array list, it actually will print out the elements inside of it, 5, 6, and 7. But that doesn't explain why we have this word integer up here instead of our word int. Well, I want you to understand this. Integer, and I should really put this in a comment, equals, it is basically the wrapper class of int. And I'll actually write that out in English. What that means is that somewhere we have a class that's public class integer, which has one private instance variable, or actually it's private. I don't know if it's private or not, but we'll pretend that it is. One for value. It has a constructor which takes a value, and so on and so forth. And the reason for that, the reason for this, this what we call a wrapper class, is that ArrayList cannot take a primitive data type. You see, it does not understand any of these primitive data types. The primitive data types, again, are the ones we've learned so far were double, integer, and Boolean. And if you've learned float, it's float too, but we won't worry about that one in CSA. So the primitive data types are those lowercase ones. Meanwhile, our uppercase ones are our wrapper classes. And those wrapper classes allow for ArrayList to actually work because a list, any list, like the array list, which is a list because it implements it, any of the lists require what are called objects. These are not objects. These ones are string, the double with a capital D, the integer with capital I, the capital B Boolean. When we made books in your bookshelf, and when we made manticores, those were all objects. These are all the primitive types. So ArrayList needs a primitive type, so it will always use these capital letter ones. The only one that doesn't need a wrapper class is the string, which is already an object. Usually these are distinguished by their capital letters. Alright, so let's say we have this array list here. I'm using ArrayList on the left side again and describing a type. Remember, that's not really necessary, though it does look nice, and I will say it's very good programming practice. It's just not necessary, and the AP exam will likely ask you, show you things like this and say, hey, is that valid? And you have to be able to identify that if you saw a bunch of them, you have to be able to identify which ones are valid and which ones aren't. Both of these are fine. Remember, the big issue is this one, where a list is on the, well, okay, the big issue is also when you don't finish a print statement. But the big issue is when you have list on the right side of the equal sign. It cannot initialize as a list. But anyways, we'll show all those later. All right. So if we want to get just one specific element in the list, let's say I'm going for this one right here, I can go in here and go get, and then I have to get its index. Remember, get 3 should get 4 because that is what's at that index. So just as always, to keep it a little confusing, we have indices that start at 0 and elements that start at 1. Yeah. So as you remember from accessors and mutators, the opposite of get is set. So let's go ahead and show that here. If I were to set the element at index 3 to 3, no, actually, let's do a different 2. Just so you can see that it is this one that's going to become a 2. It's 4 right now, but we're going to set it to 2. So if we were, the opposite of get is set, that's going to change that value. And then we can go ahead and print it out again using the getter. And yeah, you'll notice it changes from 4 to 2. And that's what we call the setter. And that is the set in the get. That's how you print out one element, and that's how you change one element. This would work the same if we had an array list of words, or just simply, an array list of strings. Notice that it works remarkably similar, even though we get warnings still. Don't worry about the warnings. Warnings are just warnings, and you can ignore them. But yeah, so that's the getter and the setter. That's how they work. Now, one thing I should also throw out there is, let's say I did this. I had a print statement and said L1.set element 3 to hello. Now here's the thing. It's being changed to hello, but will return the old value. And in this case, the old value is 2. So when I print this out, it's still going to show 2. Even though the next time I try and print this out, it's going to go ahead and actually acknowledge it being hello. For now, when we set it, it returns the original value. The original value at that point is 2. Now, by original value, I don't mean what it was up here. I just simply mean what it was before the set happened. Set will change that element and will return whatever was in there. So that's why the 2 gets printed out here, even though it is currently hello. Now, of course, if we were to go ahead and set it again back to 2, it would still print out hello. I mean, it should still print out hello, because again, it's returning the original value, the older value, we should say. Alright, so let's go ahead and get a few things out of the way. That's searching, clearing, and converting. So let's go and take a look at these. Alright, first, let's look at searching. We, of course, do need to have some new list. And I'm going to make them of strings. There we go. Hello. And I'm just going to keep adding in phrases that look nice. You know, we're gonna be nice today. Perfect. No, except for the warnings, but those don't matter. So we have this array list of 5 elements, and let's go ahead and actually deal with searching. Now you remember, hopefully, that a sequential search would be something where we say, okay, int I equals 0. I is less than the size of our list plus I. And then, you know, for whatever query we had, let's say we're looking for the word how, if L1 at, if that element is equal to our query, then we'll say, you know, we'll just have a Boolean here. Then we say, okay, well, we did found it. It is true that we found it. Break out of it. And don't have a 5 there. And that is the sequential search in the long way. And that's how we had to do it for arrays. But here's the thing, an array list doesn't actually have to do that. An array list has the .contains method. So let's again go ahead and get our query up here. And let's just go ahead and print out, let's just go ahead and see if that element is in there. So if I go ln.contains, and we're saying, hey, does the list ln contain the query how? Does it contain this value? And if it does, it'll say sure thing. And so this ArrayList contains is a really easy way of doing the sequential search. It does it, you know, automatically for you. Now, of course, if we were to say R with a space in there, it should say no. Or now it'll say no because we actually added in the else. Makes sense? And why it doesn't have the space? Well, there's no space up here. If there were a space up here, then it would see it. So that is how the contains method works, and it's pretty cool. It's a nice thing to be able to have in there, and I can even just change it directly there. I don't need this other string in the way. It's going to look for, one thing I should point out here, notice, and I'm going to go back to our normal way of doing it. Notice that if I try to just search for a comma, and you know there's a comma in here, it still is going to say that it can't find it, because it's not looking for, you know, to see if this string is present in here somewhere, or in here somewhere, or in here. No, it's going to look for this exact element. And from what it can tell, there is no element that is exactly 1 comma with no spaces. So it's going to say no for this one. It is not searching the substrings of each of these. It's going to search for that whole element in there. Now here's another way that we can pretty much make sure that we don't find it, because that's going to be our goal now. We can't find it. We have to clear things. Clearing things is a nice way of erasing the entire list. But then it's going to say, no, there's nothing in there at all, because we cleared it out. And that's why you can see that if I were to do a print statement right here, l1.size, you'll notice that it drops to 0. That is how you clear an array list. And that can be useful for you if you just need to reset it. Alternatively, I don't know if this is a longer way of doing it, but it's another way of doing it. You can say equals new array list and basically just restart it. Yeah, you know this initialization thing? You can do it again. It's just another assignment statement. And that would also reset it, because what happens is, if you're to do this, it's basically the same as doing this. Because this is the same thing it was originally, both of these lines would return it to what it originally was. So both of these lines do the exact same thing. That's why it comes up. Okay. Lastly, converting to an array. When we need to convert it into an array, this is going to be a separate method that we're Let me clear out this space a moment. Okay, thank you for waiting. All right, so let's take a look at this third thing here, converting to an array. And that is actually done with the toArray function, which doesn't mean a thing on its own. That just simply returns it. It does not change this stuff at all. You'll notice that if I were to do L1.toArray and then print out L1, it's still going to be the normal array list, right? There's all of our elements right there. I can even add in another element after the fact, and remember, warnings don't matter. And yeah, so we could still keep adding in elements. It still works just like an array list, because it is still an array list. Because this only returns an array version of the array list. You see, we would have to do something like this. System out dot, and actually I'm going to do this right here. System out dot print line L1 to array. You see, that would actually turn into an array. And I mean, L1 is still, as it once was. I guess I should make that clear. We'll see in a moment. But when we print it out as the array, because that toArray thing returns the array, it does the print out we expect. The part where it gives us this mess of letters and numbers. And if we were to print out the original array list, it would still just be an array list. Now, what we probably want to do then, if we wanted to actually get some functionality out of it as an array, we'd declare a new array of the same type as what we expected. And even if this wasn't up here, we would still, go ahead and just take a look at these elements, and that would determine what we should have here. Then we take this previously declared string array, and ignore that, sorry. So then what we do is we take this previously declared string array, and what we're going to do is we're going to go ahead and set it up to take in the array list. This is kind of a careful procedure, but if you follow along with these two steps, it will work just fine. First, notice how long our array list is. It's 5 elements. So right there, I'm going to say new string 5. And actually, to make it even better, I'm going to do L1.size, both of which accomplish the same thing. But in this case, if I were to remove one of the elements, it still works. Alright, so I do that. Then what I do is I take the array list that I was just working I take the array I was just working with, and I've allocated it, now I initialize it to, and this is going to be kind of complicated, but I'm going to casting it to a string array, casting L1.toArray, and then pass it ARR1 inside there. And with that, I do get a warning, but it at least will compile. Scrolling down, you can now see that I have the stuff set up for the array 1 to actually work, or for R1, I guess I should say, to actually work, to print out its memory address, basically, and then to print out all the elements. Alright, so printing out all the elements, again, has to be with that square bracket notation, and there you go. That is how you turn it into an array. And yes, you really should be casting it, otherwise it's going to tell you that object does not work. And what that means is, you see, you remember that array list, it implements list. List is something that sets up a very general outline for how all lists should look, including the array list. Well, how it looks up is that it has not elements of any specific type, but of type object. Type object is the parent class of all objects, everything from the strings to the capital I integers to the manticores. So this object, even though we don't say it extends it, it does actually. Every single class you've ever made is extending object. We just don't write it. All of them are type object, but they need to know specifically that when we go from that parent class object down to this child class string, we do have to cast it. So we have to go ahead and say, all right, make it a string array, and if that's possible, it'll do it. If it's not possible, like, I don't know, if I were trying to cast it to an integer array or something, it's going to say, no, that cannot be, that is incontrovertible, or inconvertible. I feel like I got the completely wrong word there. Inconvertible types, because this is a primitive, but since string does technically inherit from object, it's fine. And we can go ahead and actually get our stuff. Actually, I don't like how this prints out. Let's go ahead and print this out, not on different lines, but just like that. There we go, that looks better. Okay, and that is how we convert it into an array. Here is the last thing. This is a whole bunch, it's actually six different lists, all of which are valid. And I'm doing this to show you that really you can have any combination of list or list with the diamond notation on this left side of the equation, of the equal sign. And then on the right side, it always has to be ArrayList, whether that comes with the diamond notation or not. It also must always end in parentheses. But as you'll see, all of these compile just fine. In fact, here's me making a change and compiling the code and then running it. Does nothing, but again, it can compile and run just fine. All of these are valid. On the other end, these are invalid. Anything where we have list on this right side. It does not matter, even if I were to put ArrayList on the left side, it would not make a difference. These are both invalid. So like I said, even if I put ArrayList on the left side, still, it's not okay. Because list is abstract, list is an interface. It cannot be on the right side of this equal sign. So these are invalid, and these are valid. Keep that in mind, and you won't get tripped up. All right, see ya.